Gears. One of the fundamentals in machining that I've somehow managed to completely avoid in over 2 years in this shop. It's not that I'm afraid of them, I've just never had a need for them, I guess. So I'm a bit of a noob on the topic. I mean, I've used them, and I even know some engineering jargon, but I've never made one. Seems like a simple enough problem to solve, but gear cutters are expensive. And there's another problem. I like making tools more than not tools. So I'm going to be making a tool to make gear cutters to make gears. I'm going to make the Eureka.
Okay.
I think that's nice framing.
I don't know, you tell me. I can't see it.
I said I think it's nice framing.
Okay. I am making the Eureka tool.
Eureka!
I need to make some gears
Why?
because gears are like one of the last things, basic things I haven't done. I need to make gear cutters.
Gear cutters.
Right.
But I thought we were making gears.
You need gear cutters to make gears.
An actual thing.
This is not a gear cutter, but it's similar to a gear cutter. And there's all these teeth, right? And so the idea is that you would spin this and you could cut each tooth one at a time around a gear. It's called involute geometry.
Involute.
Involute.
Not invalid.
Not invalid.
Is there any reason that the thing that makes gears happens to look like a gear?
It's not quite the chicken and the egg. It's more like the chicken feed and then the chicken and then the egg. So what I'm making is the Eureka tool, which is a form relieving tool to cut gears. This whole thing, all it does is cut the relief on the back of the gear cutters. Are you impressed?
I'm so impressed.
You look so impressed.
Okay, so we're gonna make a tool that does something cool, and while it's doing something cool, it looks cool.
And I have the drawing. I should flip to the right page. So I didn't have to design it.
Didn't you want to design this?
Not this one. There are other things I wanted to design, but I like that this one is already designed so that I don't have to design it. I don't think I can get it all done in this video. I wouldn't want to get to the end of making this build and then not have time to actually make the gears. No, to make gear cutters. So here's the deal. I gotta make this tool, which is very complicated, and then I gotta make a cutting tool to make gear cutting tools. Once I make the gear cutters, I can make gears, maybe. There's still a maybe in there.
If you give the machinist a cookie.
I don't know what that means, but I'll take the cookie.
I
I'm
know
terrible
it means,
with literature references. And
that's a kid's book, my love.
like I said, literature references. What book is it?
If you give a mouse a cookie.
You're not going to understand what this thing does and how it's moving and what it's doing until it's all together. But there is sort of like a sub-assembly. That sub-assembly will potentially make some spinning and clicking noises. So that's my goal, is to at least have...
Okay, enough flirting. You can do that on your own time. Let's actually make something. First is a short round bit called the indexing sleeve. A perfect use for this lengthy piece of 4140. Not the most ideal setup for a short part, but a little help from the tailstock and we're good to go. I also just didn't want to spend forever cutting this down on the bandsaw. Not a ton of super interesting stuff happening here, so here's a tip. When turning a bunch of diameters in setups like this, I like to zero the DRO, take a light pass, and then measure that diameter. Then get the tool out of the way and run the cross slide in until the DRO reads the same value and zero again. Now when I back out, the DRO is reading the true dimension, making it so much easier to whip through all the diameters. But that won't save you from vicious attacks from the razor spaghetti. Speaking of razors, I think I'm due for a new look. Luckily I have Henson Shaving to help. Unlike these murder noodles, Henson Shaving makes razors designed to cut your hair, but not you. I'll get more injuries cleaning up the shop than I will from this safety razor. And despite what most people think, safety razors are not harder to use or more dangerous than the standard plastic multi-blade razors you find at the grocery store. When actual aerospace engineers are doing the designing, you get a CNC machined razor made to space station level tolerances. Literally. Before Henson got into making razors, they made stuff like the ISS and the Mars rover. So the AL13 has features that you won't find on any other competitor, like the wide open channels that just don't clog up, or the unique locating pins that better position the blade so you can be sure it doesn't reach out and poke you, or the handle that threads against a Nitronic 60 bushing to give a smooth and repeatable stopping point. And of course the cutting edge of the blade is supported way better than any other, So you and whoever kisses your mug every day will be happy to say sayonara to your razor burn. So skip the plastic, the proprietary cartridges, the packaging, and the shipping costs of monthly shaving subscriptions. Henson Shaving is here for you with the best and last razor you'll ever have to buy. Thanks to Henson Shaving for sponsoring this video and providing you, my viewers, 100 free blade refills if you use the code INHERITANCE at hensonshaving.com/inheritance or click the link in my description. Now, I think you know what's coming next.
You ready? No way.
Wow. Hi. Actually looks really good on you. I really like it.
It's supposed to be the Tarzan's dad. The problem is I don't have enough thickness to fill it out. So I just look like
in other regions to fill anything out though.
I feel like the guy from, what's that movie, that show, Blackbird?
The serial killer.
The serial killer in Blackbird. I kept just kind of like,
It's a nice chamfer. That really doesn't offend. Why doesn't that offend me? I feel like that should offend me more.
Miss Victoria Mommy over there likes the old...
You will never watch Pride and Prejudice with me ever.
No. So you like it.
I do.
It's getting hot in here. Oh. I figured this one you would love it or you would be disgusted by it.
It's following the trend line of I like more facial hair as opposed to less.
Yeah.
Well, I certainly wasn't expecting that response. There might be another hot date in the cards for me. Until then, let's get back to work. Unless you have a well-seasoned dichrometer, you probably can't tell these diameters aren't finished. I've left everything about 20 thou larger for some finishing passes I'll get to shortly. I've got some work to do on the other end, so back in the forge awl to true it up, and then facing this down to its final length. Now everyone knows a good indexing sleeve has a hole in it, and as you can see, this one's missing its beauty mark, so that's next. And I'm afraid it gets a little boring here for a second. Still awake? Good. As a reward, let's do something more interesting. With all the metal I just removed from the inside, things are likely warped and now the outside is no longer true to the inside. And you can bet your buttered bench vise I want it to be. So we're going to hold this between centers for the final cuts. I'll mount the first center in the chuck and take a pass to true it up. Then I can pop my sleeve between it and the live center and squeeze the bejeez out of it. Emphasis on the bejeez. Friction is all that's going to keep this part spinning with the lathe, so this needs to be tight. One last turning op is a thread on this end, but I've got myself a little pickle here. That ain't gonna fit. And while these words are enough to raise the self-esteem of even the smallest gherkin, it doesn't help me. So let's fix that. That ought to do it. Now these threads should be a cinch to cut. I guess I wasn't heavy enough with the bejeez. I shouldn't be able to turn the part by hand like this. Maybe it came loose, or the contact point with the center wore out a bit. Whatever the case, there's no way this can be the first donation to the new box of shame. So I'll give this a gronk and another go. I didn't get very deep before that little hiccup, but I'm still going to try and pick up where those threads left off anyway. I can get this pretty close by engaging the thread feed without anything spinning, then adjust the crossfeed and compound slide until things are lined back up. This new set of cuts should remove that little boo-boo like nothing ever happened. That's how that was supposed to go. And even after starting at a slightly smaller diameter, I'm able to hit the right thread dimension, which just leaves one final job on the lathe. The chamfers, of course. Turned out alright despite the blunder. Let's finish this up on the mill. There are 12 equally spaced notches around the outside. A perfect job for the rotary table and chuck. But that's a whole bunch of setup that I'm not keen to do. So I'm going to keep this simple and just use the collet block. The notches have a convenient 60-degree angle, so a dovetail cutter is the obvious choice, and positioning is just a matter of getting touches on the top and side perimeters, then letting her rip, and rotating the collet block between passes. Now you might be thinking to yourself, won't that only make 6 notches? And you would be right. So after the first 6, I'll change how I'm clamping the block, then lather, rinse, and repeat. Lastly are a pair of wrench flats, then a final spot face that will make sense soon. Top-notch work, wouldn't you say? Nice. Next up are some fastening bits, which I'm going to make out of bronze for no other reason than it's pretty. This hunk already has a hole poked in it, so that will save me from poking my own. This first piece is just a ring, so after facing, turning, and boring, I'll pop some chamfers on here and part this off. The ring isn't finished, but I want to go ahead and whip up the nut while I'm here. Most nuts are threaded, and this one is no exception. So after some chamfering, I'll switch to the thread cutter to make some clearance at the back of this bore, then cut the thread to a perfect match with the indexing sleeve. Nailed it. Or should I say screw... Oh, that's why we don't say that. Okay, anyway. After parting this off, I'm left with 2 rings that I somehow need to hold to finish up the other sides. Luckily I have this exquisite specimen of high purity polymeric fixturing medium. Perfect for a quick and dirty mandrel. I've gotten used to the razor spaghetti, but these chaos noodles, well, they're something else. After equal parts cutting and detangling, the first ring presses onto the mandrel, and then it's a simple matter of finishing the other side. The trick now is getting this off of here. Easy enough with a boring bar to remove almost all the material, and then a hammer. After a slight modification to the mandrel, the nut is a similar deal. Back on the mill, the nut gets its second most useful features, some wrench flats. Then a set screw hole is popped in the ring. Alright, that's 2 fancy bronze parts whipped up. Let's fit them together. The spot face I added earlier is for a set screw that goes here. And if you weren't aware, if you leave candy in the shop for long enough, it becomes hardware. I'm going to go ahead and say the bronze was a good choice. Next I'll work on the so-called anchor plate. And looky here, the perfect piece of stock already squared up and milled to size. How convenient. I guess this means we can jump right into the fun stuff. After locating the part, I'll spot drill a few hole locations that really just won't make any sense until later. So this first one is a threaded hole for a pivety-wivety, then a reamed hole for a pokey-podoki, a slot is milled for the slidey-glidey, and this last hole that even my girthiest drill can't satisfy. So I'll bring this guy in to settle the bore. After a little sketchery with the boring head insert, I can also pop some chamfers on this big guy. Then of course everything else gets this treatment as well. Looking pretty sharp, or not sharp actually. I guess that was the point. Okay, I'm done. Despite my complaints before, I can't avoid the rotary table for this next round of operations. And yes, I really did move this thing twice just to get this sequence. I'm going to start with the big honkin' radius around this bore. And to get it centered up, I'll use the coaxial indicator like I did to locate the table. Then gronk the bejeez out of the clamp so this sucker doesn't try to run away. Now I just slapped this on here, so there's no chance it's actually square to anything, but it's easy enough to tram with the indicator by rotating the table, and resetting the zeros on the perimeter scale and the handwheel dial. One last thing, the book drawings don't give much in the way of angles, so I whipped up my own CAD drawing to get what I needed to know. Now I can already hear the bajillion of you screaming at the screen that I shouldn't be climb milling like this, and I know, but I have a reason. If something is going to move, I wanted to move away from the cutter rather than get pulled in and scrap the whole part. Fortunately, the gronking I gave the clamps made this a non-issue. After swapping to a finishing mill for the final pass, I'll pop some proper sexy chamfers on here before changing setups. Seriously, how are chamfered rounds so satisfying? The next setup is for this long skinny end, so a gauge pin helps me locate the end of the slot. Then some more naughty bad climb milling. At this point, most of the rest of this is just decorative. Actually, all of this rotary table work is decorative. This piece was technically usable right after making the holes in the slot. But if you thought I was going to stop there, you certainly haven't been around here long enough to know the lengths I'll go to make a nice corner round, no matter how small. Only downside of more setups is more chances for mistakes, like this little guy that I somehow miscalculated. So back to the first setup so I can take care of that. This looks fantastic. This side anyway. I still have the whole other side to chamfer. And despite my harping on earlier, I'm not particularly thrilled about doing all those setups again. Thank goodness for die grinders. Hey, I can be pragmatic, when it's convenient. For me. Besides, hard to even tell the difference. Now there's one last feature on this part that I almost forgot about. A couple of 440 threaded holes in this side. Alright, that's most of the big hairy pieces taken care of. So now let's work on the little hairy paws. Not those, this. The ratchet paw. And you wouldn't believe it, another perfectly sized piece of A2 tool steel for the job. How fortuitous. Let's dive right into the holes. The paw itself actually only has one, but I need 3 for this to all come together. The other 2 will make sense after I counterbore this one with none other than, you guessed it, the boring head. Now let's make this square less so. Another job for the rotary table. First is a straight cut at 20 degrees that technically doesn't need to be made on this rotary table, but it conveniently uses the same setup as the first rounding operation. And of course I put together another quick drawing to fill in the missing angles from the book. Next is a job for these 2, or well, now it's 1.5 holes. I milled this one away slightly, but it will still serve the purpose of locating the part so I can cut the outer radius. Something ain't right. If all my math checks out, these 2 curves should have blended together perfectly. Nothing like this piece of doo-doo. But I'm now noticing that this first curve we cut doesn't even look remotely centered on the hole it's around. So it seems I either boned the setup or it boned me. Whichever the case, I know someone who appreciates a good bone. Okay, let's try this again. No frickin' way. Another prepared piece of stock, and this one even has the holes in it. I probably should have looked a little harder the first time and saved myself some work. At any rate, it means I can more or less pick up where I left off. And this time, we'll go heavier with the clamps and lighter with the cuts. That's how that's supposed to look. The last arc is the inner one, which means clamping spots are sparse, but manageable. Alright, after a look with the old grinder, the ratchet pawl is done. So now for its mounting screw. I wonder if... Yeah, it was a long shot. I guess I'll have to make this one. Should be a lickety-split job though. Since the ratchet pawl still needs to be able to spin, this is going to be a shoulder screw. So one diameter is for the head, a smaller one for the shoulder, and then the last is for the knees and toes. Oh, wait, wrong audience. This is for the threads. And once again, the Hemingway tool is sent to me by my friend Eric, come in clutch. No, literally, this clutch die holder is perfect for making the threads. And then this rotary broach pops a nice hex hole in the other end of the screw. Bada bing. Now this just goes in here and bada boom. Looks like I got all the dimensions spot on too, since this is able to spin. So now we're just one small component away from some glorious clicking noises. I'm going to need a spring, which starts with this plate, and while it's not the finished thing, it's at least at the right thickness. This gets 2 tiny mounting screw holes, then I can mill it mostly to size. I say mostly because now I have this little nubbins to clean up. But just like the last small part, work holding is a little tricky. I can't use my normal parallels because they're the same thickness as the part and I wouldn't be able to clamp them. Luckily my late grandfather foresaw this exact issue of mine 30 years ago when he bought these. Wavy parallels. A bit of an oxymoron, but they're still parallel how they need to be and will let me grab onto the thinnest of parts like this. Pretty exciting to have just the right tool right when you need it. So exciting in fact that I forgot to record milling away the nubbins. So just enjoy the drilling of this teeny tiny hole. Alright, there it is. The spring. What? I mean, it technically has a modulus of elasticity, so it will do spring things, but not at the order of magnitude I need. Good thing I have some spring wire. Okay, now it's a spring. And after throwing a couple of screws and this dowel pin in here, we're ready to make some clicking noises.
Oh.
That is too good. I know someone who will appreciate this as well.
Did you make something to show me?
I made something. It's show and tell time.
Show and tell time.
You
Okay,
ready?
our favorite time of the day.
Okay.
Pretty.
You're damn
have-
right it's pretty. Uh-huh.
Oh!
That's a proper ratchet, right?
You have a spring.
Yes.
Very nice cutouts.
Yes.
Approximately 12 of them.
They're notches.
Notches. 2 sets of wrench flats.
Yes.
Very nice.
Yes. Very nice.
It looks very
That's
good.
all I get.
Wow!
Thank you.
There you go. You did it awesome!
This is 50% of the way through the project. And, about this much more to make of different pieces. Another ratcheting mechanism. So there's double ratchets.
Oh my gosh, we're gonna get 2 clickety clicks?
Yeah, it's gonna go. No ball busting. You got nothing else. What about this?
I hate it.
You do hate it now.
Yes. It looks better when I cover up the bottom half of your face.
You bring out the pterodactyl in me.
I think we're tired.
We are tired. It's been a long project.
Not really.
Shut up.
It's been a project, but it has not been a...
Shh, you're interrupting. Okay, yeah.
Okay, so it may not be a finished tool, but I held up my end of the bargain. It does the spinny, and it does the clicky. and it ended up looking pretty svelte in the end too. But I needed to do more than just look fancy and make noises, albeit very satisfying noises. Tools, after all, do jobs. So stick around for part 2 of this build, where if all goes well, I'll finish this bad boy, make something with it, and maybe even feel compelled to shout, Eureka! As always, thanks for watching, and see you next time.
Hi, sweetie. Hi, Pookie Bear.
Ugh.
Hi, Pumpkin.
No! Okay, so... I want to see your curly cues. Please keep your pants on, though. Those are a very nice color.
A $5 chip, because the bronze I used is really fucking expensive. Well, I got this for you. Will you come and get it?
You got it for me? No, you pulled it out of the garbage for me. I feel so special.
Oh, come on, way back here.
No, just a little bit. Come forward.
Why don't you say back that ass up?
This sounds like a very complicated thing that's going to require you to be in the shop until 2 a.m. to complete.
When's the last time I've been into the shop until 2 a.m.?
11 p.m.
So your answer to when was the last time I've been in the shop until 2 p.m., your answer is 11 p.m.
Boxy knows what I'm talking about.
Technically, you were in the shop with me, so.
And if I hadn't been, you would have been in the shop until 2 a.m., so there!